Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, dear students. Try to answer these questions, please, and watch the video to know the answers of these questions. Let's start. Here we have the first question is about measurement. A student wishes to measure accurately the volume of approximately 40 cubic centimeter of water. She has two measuring cylinders, a larger one that can hold 100 cubic centimeter and a smaller one that can hold only 50. The water forms a meniscus where it touches the glass. You have here two cylinders, a bigger one and a smaller one. We want to measure 40 cubic centimeter. This one can hold up to 50. This one can hold 100 cubic centimeter. Okay, look at the question. Which cylinder and which water level does the student use to ensure an accurate result? Look here. To get an accurate result, the smaller the cylinder is, the more accurate result you can get. Again, as long as a smaller cylinder can hold the amount of liquid we want to get its volume, it is more accurate. For example, here, this is 50 cubic centimeter and this is 100 cubic centimeter. This can hold up to 50, so it can hold 40. This means this is the best to be used to get an accurate result. This is one thing. So we will choose the smaller one. Okay, so it is either C or D. For water level, the bottom of the meniscus. We measure at the bottom of the meniscus. Okay, so it is C or D. So we have here the smaller one and the bottom of the meniscus. So the answer is C. Number two, the diagram shows a rectangular metal sheet close to two rulers. This sheet here, and we have here two rulers. What is the area of the metal sheet? Area equals length times width. So if we get the length and width, we can get the area. Look at the area here, or sorry, the length and width. The length starts from 10, look at this, and ends at 40. This is 40, this is 50, it is between them. So this one is 45. So the length equals 45 minus 10 equals 35 centimeter. Good. The width starts from this point. This point is exactly the mid distance between 0 and 10. So it starts at 5 and it ends at exactly 25 centimeters. It ends at 25 centimeters. So the length, sorry, the width here is 25 minus 5 equals 20 centimeters. Good. The area, as we said, equals length 35 times width, which is 20, equals 700 square centimeter, because, or centimeter square. Look at this. This is centimeter and this is centimeter. Centimeter times centimeter is centimeter square. So the answer is 700 square centimeters. A student uses a meter ruler to measure the length of a sheet of paper. It's okay. Which measurement is shown to the nearest millimeter? Okay. All the results are in meters. Okay. What is the relation between millimeter and meter? Look at this. 1 millimeter equals 0.001 meter. Okay, so we have here, the first one is 4 decimal, the second one is 3. This is, letter C is 2, letter D is only 1. So the answer is B. We have here 3 decimal digits. A student is measuring the volume of three liquids using three different measuring cylinders. Look at this. The table here we have this volume and this volume, this volume. The table shows the volumes recorded by the student. Okay, cylinder 1 is 1.2, 2, 2.2, 3, 25. Which readings are correctly recorded? Look at this. We have here the first one. This is 1, this is 1.5. So this one is 1.1, 1.2, 1.3, 1.4, 1.5. Look at the volume here is 1.2. Okay, cubic centimeter. This one, this is 1, 2, 3. So this is 2. And I have here only 5 spaces. So this one is 2.2, 2.4, 2.6, 2.8. So this one is 2.4. What about this one? This one is here. This is 20, this is 30. So this is 22, 24, 26, 28, 30. This one is exactly here between 24 and 26. So this one is 25 cubic centimeter. Okay, let's compare. Number one is 1.2. Yes, 1.2. Number two is 2.2. No, number two is 2.4. So this one is wrong. Number three, 25. Yes, 25. So the answer is letter C, 1 and 3 only. A student uses a ruler to find the volume of water in a tank. She measures the lengths EF, FG. Where is EF? This is EF, and this is FG, and she needs to get the volume. What other length does she need to measure? Look at this. The volume of a cuboid like this equals length times the width times the height. We have to look at the 3 dimensions. Look here. This is the length. This is the width. Where is the height? The height can be FK or GH. Okay. GH is not here. FK is here. What about FJ? FJ is from here to here. She needs only to get the volume of the water. This is the water here. But FJ is of the tank itself, the height of the tank. But the height of the water is only FK. So the answer is FK. The diagram shows an enlarged drawing of the end of a meter rule. It's being used to measure the length of a small feather. Small feather here. Look at this. Please pay attention to these things because sometimes they are tricky. Look at this. The end is at here, this point. We have here 20, 30. We have 10 spaces. So 21, 2, 3, 4, 5, 6, 7, 8, 9. So this is 29. It doesn't start from 0. It starts from here. It starts from 10. So the length equals 29 minus 10 equals 19. So the answer is 19. Is it 19 centimeter or 19 millimeter? Look at this. Millimeter is up, so this is millimeter. In centimeter, we have here 1, 2, 3. Okay, please. This example is tricky. You have two things. Okay, you have to look at the grade itself, where does it start and where does it end, and to the unit used here. We are here talking about 29 minus 10 millimeters, so it equals 19 millimeters. So the answer is 19 millimeters. This one is wrong. Okay, nice one. The diagram shows a measuring cylinder used to measure the volume of a small stone. It's very easy. You know that. We have here two volumes. What is the volume of the stone? The volume here is 10, and we have here, these are 10 and 20. These are five spaces, so each one is 2. So this one is 12, 14, 16, and 18. Okay. After immersing the stone, the volume increased to reach 20, 22, 24, 26. So the volume is the final volume minus the initial volume, or the volume of both water and the stone minus the volume of the water only. So the answer is 26 minus 18 equals 8 cubic centimeters. Now, to measure the time interval, okay, sit here, look at the diagram. We have here the pendulum is swinging between P and Q. Okay, which method is used to find the average period of oscillation for the pendulum? Look here. The average period, average means total over number. Don't forget this. The average period of oscillation means we need to get the time taken for one oscillation, the average time for one oscillation. Look here. Oscillation, if we start with P, it has to go from P to Q and back to P. From P to Q and back to P. Look at this. Measure the time it takes to swing from P to Q? No, because it is not an oscillation. And to get the average, we need to get a number, the time of a number of oscillations, and divide the total time by this number. Measure the time it takes to swing from P to Q and back to Q to P. Good. This is one oscillation. 10 times. Brilliant. And divide that time by 10. Measure the time it takes to swing from P to Q to P. This is good. 10 times good. And multiply. No. Measure the time it takes to swing from Q to P. No. So the answer is P. We get the time of 10 oscillations and divide this time by 10. Which list contains only vector quantities? Now to the vector quantities and scalar quantities. Again, the scalar quantities have only magnitude, such as mass, temperature, length, speed, energy. All of these are scalar quantities. The vector quantities have a direction or have directions, like force, weight, velocity, acceleration, momentum, gravitational field strength, and electric field strength. Okay, look here. Which list contains only vector quantities? Here in A, only acceleration is a vector quantity. This one is a scalar, and this one is a scalar. B, electric field strength. Yes. Momentum. Yes. Weight, of course. C, energy. No. Mass. No. Temperature. No. All of these are scalars. D, force. Yes. Time. No. Velocity. Yes. So the only one which has only vector quantities is B. In which row are quantities correctly categorized into scalar quantities and vector quantities? Firstly, with a scalar, mass and energy, yes. Gravitational field, no. Time, yes. Speed, yes. Momentum, no. Distance, yes. Energy, yes. Okay, so we have A and D. Okay. Weight and acceleration, yes. Yes, they are vector quantities. Force, yes. Field strength, of course. Distance, no. Force, yes. Velocity, yes. Temperature, no. Which one has correctly categorized quantities? Yes, it is A. Two forces with magnitudes F1 and F2 act on an object at right angles to each other. What is the magnitude of the resultant force? Look at this. To get again the resultant of vectors, if the two vectors are perpendicular to each other, for example, this is F1 and this is F2, the resultant is the hypotenuse. The hypotenuse here is the resultant, and it equals the square root of F1 squared plus F2 squared. So it is the square root of the sum of the squared legs or vectors. So this is this one. This one is not correct. This one is not correct. This one is not correct. So A is the correct answer. Here the diagram shows a solid object on a flat surface with two forces acting on the object. I think this one is very easy. If this object is affected by a force 4 Newton to the right and 3 Newton to the left, so this box is affected by 1 Newton to the right. It is 4 plus negative 3 or minus 3. It equals 1. I put here 4 positive and 3 negative because they are opposite. The resultant here is 1 positive, so it has the direction of 4. 4 is to the right, so the resultant is 1 to the right, 1 Newton to the right. Here, if we want to get the resultant here, the resultant Z. Okay, again, guys, to get the resultant, the two vectors are drawn after each other. And the resultant closes this triangle. So if this is X and this is Y, this is Z. Okay, they have to be the starting or the starting of the new one is at the end of the first one, like this. One and the second, or the other one. Where are X and Y? X and Y here, they start from the same point. No. X and Y start from the same point. No. X and Y are after each other. Yes. But Z here continues like them. No. Z must close it. Look at this. X and Y. Yes. This is here correct, but this is not. This is here correct. And Z closes this. So the correct answer is D. The correct answer is D. Velocity is a vector quantity. State how a vector quantity differs from a scalar quantity. Very easy. Try to answer it. Yes, vector quantity has a vector has a vector quantity has a direction, and the scalar but the scalar does not have. Or you can say that the vector quantity has both magnitude and direction, but the scalar has only a magnitude. Here, the last question is about how to get the resultant. This is here a river where water is flowing from the right, okay, like this. And this swimmer starts at point P and swims at a constant speed 0.72 meter per second relative to the water and at a right angle to the current. Determine relative to the riverbank, both magnitude and direction of the swimmer's velocity. Look at this. The swimmer is swimming straight like this, but the water is taking him in this direction. Will the swimmer reach this point or drifted to another point because of the water? Yes, of course, yes. he will be drifted. This is the direction he will take. So again, to get the resultant, we can draw it simply like this. This is his velocity, 0.72 meter per second, and the speed of the water is 0.54 meter per second. The resultant must be in this direction, because we say that we draw them after each other, and the resultant is closing this figure. Okay, how to get it? Of course, we need to get the magnitude and the direction. The magnitude is easy. The resultant, or the magnitude, we can write it like this, equals the square root of 0.72 squared plus 0.54 squared equals 0.9 meter per second. Okay, what about the direction? The direction means we need to get the angle with the horizontal. River bank. Look at this. This is the river bank here, and we need to get the angle here. How to get the angle? We get this opposite, which is 0.72 over the adjacent, which is 0.54. Look at this. To get the angle here, the angle equals tan or inverse tan. The opposite, 0.72 over 0.54 equals 53 degrees. So this one is 0.9 meter per second, and the direction of the velocity is 53 degrees with the river bank, or relative to the river bank. Or you can get it like this. You can say that tan, you can get the angle here. Okay, shift tan 0.54 over this and get 90 minus it. But this is easy. So you can get it again like this. You can say that the angle here, theta equal tan minus 1, 0.54 the opposite over 0.72. From this, you can say that it equals about 37 degrees, but this is with the vertical. With the horizontal, the angle we need to get equals 90 minus 37 equals 53 degrees. This is the end of the practice. Thank you very much. See you next time. Inshallah, I hope that you understood everything. Assalamu alaikum wa rahmatullahi wa barakatuh.